Hello students, today's objective is number and operations. The student applies mathematical process standards to represent and compare whole numbers. The relative position and magnitude of whole numbers and relationships within the numeration system related to place value. The student is expected to D, generate a number that is greater than or less than a given whole number up to 120. So this is the objective for today, and we're going to set this aside so you can reference to it, and we'll get back to that at the end of the lesson. So we are going to do this by solving a word problem using a concrete representational linear model, which would be our number line, and a concrete set model, which will be our double tin frames. So first, I'm going to start off by introducing the question, which is, Sally and Joe each have a bag of apples. They want to combine their apples and donate them to a homeless shelter. If Sally has 11 apples and Joe has 19 apples, what is the total amount of apples that they will donate? So first, we'll take these two double tin frames, and this tin frame will represent Sally's, and this will represent Joe's. So for Sally's, she had 11 apples. So each tin frame represents 10 units, which is one whole. Each of these single markers represents 1 unit. So we know that she has 11, which is 1 more than 10. So we know that we need to fill up 1 whole tin frame. And we don't need to count because we know that 1 tin frame represents 10, and we know that 1 more than 10 is 11. So here we have 1 set of 10 and 1 ones. So next, we will do Joe's. And in the problem, it said that Joe had 19 apples. So we know that Joe will have 19 apples. So we will set the red markers to identify his and fill this up to 19. So there we know that we have 10. And 9 is 1 less than 10, so we know that we need to fill all the squares on the second tin frame to make 19 except for 1. So here we have 19. So 10, half of a tin frame is 5, which is 15, 16, 17, 18, 19. So here we have Sally's 11, Joe's 19. And Joe has 1 set of 10 and 19 ones. So 2, we want to find out what is the total number of apples that they have together. So to do that, we are going to take Joe's and add them using addition to Sally's apples, which is her tin frame. So we will do this by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're just adding in his apples right now. And now we can see that we have a total of 10, 20, 30 apples. And we know this because each tin frame represents 10. We have 3 tin frames, and that is 30. So now we have 3 sets. We regrouped to make 3 sets of 10. And we see that it is 30. And so we found the total with Sally's 11 and Joe's 19. We added them using addition to find the total. And what was the total? The total was 30. And also, when adding these, we added Joe's 19 to Sally's, but we could also do the same thing and add Sally's to Joe's. So let's put all of Joe's back on his tin frame. And we can see again that Sally has 11 and Joe has 19. So according to the commutative property, A plus B equals B plus A, we know that we can add Sally's apples to Joe's and Joe's apples to Sally's and get the same answer. So let's do that. We added Joe's to Sally's. So let's move Sally's to Joe's. And here we will have 1 unit This 10 frame is full, so no more can go in there. This 10 frame has 1 unit needed, so we'll move this 1 unit from Sally's over into Joe's, and we see again that we have 3 sets of 10, which makes 30. So we saw that 11 plus 19 equals 30, and 19 plus 11 equals 30 according to the commutative property. So that's how we solved that problem using the double 10 frame. Next, we're going to use the number line. So, a common misconception that students have is each space, students make assumptions that it's all the same. But actually, number lines can have different kinds of values. So, on this number line, for example, we could start by 2, 4, 6, 8, 10, and each space in between represents 2 units. And so every time we move forward, it's adding 2 units. So we can plus 2, plus 2, plus 2. On this number line, if we were to do that, we could add by 5s. 5, 10, 15, 20. And each space in between would represent 5 units. So every time we would move forward, it would be plus 5 each time. Today, we're going to do a different method, which is by ones. So each space in between represents 1 unit. And since each mark is 1, we are adding 1 more each time we are moving down the number line. So, we remember from the problem that Sally has 11, and we want to add Joe's 19 apples to get the total. And we're going to say that we don't know the total right now. So, we are going to start by adding to our number line with 2 markers. Purple will represent Joe, and blue will represent Sally. So we're going to start off with Sally's 11 apples. We are going to move forward for starting here at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's where we stop because that's how many apples that Sally has. And I have these marks, and each of these is plus 1. So that's how we keep track on the number line of how many we have already marked on the number line. So we know that this represents 11 apples. And so remember, we wanted to use addition to add Joe's apples. So on the number line, we're going to start where we left off at 11. And we're going to add 19. So if I count adding on from 11, I will say 11, 12, 13, if we start at here at 11, I'm going to start at 1 again. Even though I know this is 11, I'm adding on. So I want to be able to know how many I have put, which is 19 that I need. So I'm going to start at, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, oh no, 17, 18, 19. So, we see here that we ended up on, goodness, sorry about that, we ended up on 30. So, we know that each of these represents plus 1 unit, adding forward. And we have 11 plus 19, and we ended up getting 30, which is what we figured out with the double 10 frame. So we can see how many we've added to get the answer. So those are just two simple ways to determine the sum of two numbers using the double 10 frame and the number line.